Mark P. Otten back with you. All right, so you want to do a hypothesis test. Cool, that's awesome. Which one should you do? There's so many. This decision is so difficult. Okay, well, this roadmap is here. I created a few years ago to help in this situation and also to kind of bring together the different options that I cover in my statistics class for undergrad and then also summarize some of the hypothesis details and test statistic details for each one. This roadmap should not necessarily be used as a guide for like, how do I do this in SPSS? Well, there's some SPSS commands in there that I included, but I have separate videos on SPSS operations for each one of these. So I would probably head over there for that, because this is just like the leading edge of it in terms of like what the commands look like. Same thing for the math. Doing that in Excel is going to refer to my Excel videos for that. This, however, is I'm going to take you through some decision making here, some guidelines for how to navigate a chart like this, a decision like this. And first of all, I've got the golden rule of hypothesis testing down here in the lower left. So let me show you that. I talk about this in my intro to hypothesis testing video. It's three things that are like, if one is true, the other two always have to be true. If the p-value is less than 0.05, reject the null hypothesis. And the test statistic is also then going to be greater than the critical value. If the test statistic is greater than the critical value, then we know that the p-value is going to be less than 0.05 as well. So it goes each way. And so that applies to all of these, any of these hypothesis test procedures that cuts across the whole chart here. So, okay, besides that, it's good to start at the top, and it's good to take this step by step. So a lot of times students will read a homework or a word problem and they're like, regression. Like they just like jump to the guess. And I'm like, wait a minute, how'd you get there? And if you unravel how you got there, a lot of times things are done out of order. So let's go in order, and I'm going to carry through at least one example here to try to give you some guidelines. So the top is like, there's this line here, and it says on the left, one variable, and it goes across two variables, and then one independent variable, and then two independent variables. So that's basically four categories. And where you go in this chart really depends on the decision on this. So really it's like, is there at least one independent variable? That's the question you should always ask first when you're trying to do this. Is there at least one cause or source of variation in your data that is implied by the word problem? So if I hypothesize statistics students have more fun than non-statistic students, let's say, or doing statistics is more fun than not doing statistics. Well, either way, the cause is implied there. The cause is doing statistics, and the result is having fun, right? The reverse would be like, having fun causes you to do statistics. That's not what I said. It's different, right? So if it's different going one way than the other, you know there's a cause. There's a direction there. Statistics causes you to have more fun. Fun does not cause you to do statistics in this case, the way I set it up. So there's an independent variable there. And is there more than one? I just said doing statistics, right? If there was a second one, it would be like doing statistics and drinking coffee will cause you to have more fun. Well, then there's two independent variables. Each one causes you to have more fun. So then you'd have two. So the way I set that one up, it would have been a one independent variable, one cause situation. Now, so then that like really narrows down what you've got here. You're in the center section of the chart here under one independent variable. And now you've got like only 4 options as opposed to whatever, 10 that are on this chart. So you really made a lot of progress just by answering that question alone. You didn't even worry yet about whether the data is categorical or whether groups are independent, whatever is coming next. It's just, was there an independent variable? If so, how many? And then that's the key to really, that's half the battle. So you can stop the video now if you want, half the battle is over. Some research studies are correlational, as they say. That's the ones where it's one variable or two variables with no independent variable. So in that case, you could make a hypothesis like doing statistics and having fun go together, right? There's no cause, right? I'm doing statistics, I'm having fun. I don't know which one came first. So if the word problem is set up that way, research problem is set up that way, then you go over to the no causation, no independent variable section. And then you decide, is there one or two? In that case, having fun and doing statistics, that was two things. That was two variables. So that would be a two variable situation. And then you're down to two options, correlation or chi-square. And you go from there. So again, that initial decision, is there an independent variable or cause or not? That should drive your decision making first. Okay, so let's look now a little further down in the chart. We can talk about continuous and categorical variables next. So depending on where you are, so let's say we choose the independent variable route. We're saying doing statistics is the independent variable and having fun is the dependent variable. Is the IV continuous or categorical? Well, I didn't really say. How are we measuring doing statistics? So let's say it is number of hours spent on statistics. Number of hours spent, that's a continuous variable, right? It's on a number line. Continuous variables are typically 0 to 100, 0 to 50, whatever. Decimals are possible. Categorical in that case would look like, did you do statistics or did you not do statistics, right? We have two groups, let's say, and one did statistics and one did not. Then we're in the categorical section for the IV. Now notice we're looking at IV here, the statistics variable. That's a key as well. So we're not deciding anything about the dependent variable in that case. We declared the independent variable as doing statistics, so we're working with that. If you jump and start looking at the dependent variable, then you might get in trouble at that stage as well. So again, going in order. We've determined one independent variable. We're wondering if the independent variable doing statistics is continuous or categorical. Suppose it's number of hours done, statistics. That's a continuous variable. So then we're pretty much done here because, I can zoom in here. We've got a continuous IV. And then the only remaining decision in that section is the DV continuous or is the DV categorical? The DV in this case is having fun. We didn't really talk about how we're measuring fun, but you'll also notice a dead end in the chart here. If the dependent variable is categorical, then we're going to logistic regression, which I don't cover typically in my undergrad class. So the answer will never be logistic regression. So you're pretty much looking at regression here regardless of the situation. Now, if you had declared the IV categorical, then you have a little bit more decision making here. So we could talk about that as well. If doing statistics were categorical, if I had one group that was doing statistics and another group that was not, and then compared those two groups on amount of fun had, well then the IV is categorical, it's two groups, statistics or not. Then we go into this other decision part here for ANOVA, which is IV categories are independent, IV categories are dependent. So in that case, our IV categories are groups. One group did statistics, one group did not. They're different groups, so they're independent of each other. And so we have a one-way independent samples ANOVA. If they were dependent, what would that look like? That would be like you do statistics today and then tomorrow you don't. And you compare fun. You had more fun today or tomorrow. That's you being measured twice. That's like repeated measures. So whenever it's the same person over time, there's a dependence there. IV categories are then dependent. So like maybe you just like to have a lot of fun. So you're going to have fun today doing statistics, and you're also going to have fun tomorrow not doing statistics. Or something else causes the dependence there. But whenever there's repeated measures, whenever it's U being measured multiple times across time, then the IV categories should be assumed to be dependent. And so you'd have a one-way dependent samples ANOVA. By the way, what does one-way mean? So much terminology here. Hopefully you're still with me. One way means one independent variable. Easy enough. But the textbooks sometimes drop that terminology in there and you're like, where did this come from? I'm not on a one-way street. Okay, so we've talked a little bit about the one independent variable section here. Let's go over to the zero independent variable section. Let's back up to that section and talk about decisions here. So I said, okay, maybe there's no cause. If there's no cause, that's pretty common actually in psychology research. Then we go over to the left side here. At least it's on the left side for me. Yeah, it probably is for you. And we look at one variable or two variables. So in the statistics example, let's say statistics and fun are going along at the same time. The hypothesis would be that there is a relationship between doing statistics and having fun. We don't know which is causing the other. Maybe you're already having fun, therefore I'm going to do statistics because I'm having fun. Yeah, it seems less likely, but could be. We're trying to adapt this example to any scenario here. So if that were true and we were measuring amount of hours done statistics and amount of fun had on some sort of continuous 0 to 100 or something like that scale, then we'd be looking at a correlation because data is continuous for fun and data is continuous for statistics done. If it was categorical, we would be looking at a chi-square independence test. What would categorical look like there? That would be like 2 days doing statistics and not, and then 2 more days having fun and not. So then you have like 4 combinations. You're like statistics and fun, statistics and no fun, no statistics and fun, and no statistics and no fun. So suppose there's some sort of arrangement where you're like able to have fun or not. I don't know. That seems like kind of a weird one, but yeah, as long as you had those 4 categories, right? Statistics or not, right? That's categorical. And then fun or not, that's another categorical situation. And you cross those, you have the 4 combinations. Then you're looking at a chi-square with categorical data and no causation. Going even further to the left, if we're moving down to just one variable, we're eliminating fun and we're only looking at statistics. This one is just like, there's only one column of numbers in your data and it's amount of statistics done today. You're not comparing it to anything. This is going to be a t-test if it's a continuous variable because you're like, okay, the mean is 4.5 hours of statistics done. Wow, that's a lot in one day. That's like me. So the mean, and so then you're compared, so then like typically with a t-test with one sample there, it's a continuous variable, number of hours done statistics, and you're comparing it to some number like 1 hour. And so did I do more than 1 hour of statistics today? Yes, that would be the conclusion. So once you're down to one variable, there's no causation, and sometimes you're a little bit limited in how much you can really conclude. But it's common, these types of tests. If data was categorical, it would be like the thing where you either do statistics or you don't, and then you're trying to figure out maybe there's 30 days in the month, and I did statistics on 20 out of those 30 days. Is that more than half the month? Or did I do a lot of statistics in this particular month? And you compare it to some benchmark of what a lot is. That's a chi-square test. There's no causation again, but you're trying to just figure out if I spent more days doing statistics than not. Okay, so those are your that's your correlational section. Again, no independent variable. Let's go all the way back over to the right and look at the 2 independent variables case. This one is when you can start adding things up to really make more in-depth conclusions based on, in psychology research, when you add in predicting human behavior is hard. Like if we're trying to do real research here, so like Is there only one cause of my behavior? No, there's like a million. So adding in a second independent variable is often the beginning of understanding people better. So these two IV studies are common. They add layers to your understanding of humans, and they also add layers to your statistics. So we talk about these in my class, and then let you kind of dive in as deep as you want in terms of adding independent variables to your studies. But okay, so with the statistics and fun example, one more round of that. What did I say? So the first thing to cause having fun is doing statistics. The second thing to cause having fun is drinking coffee. So then if you are hypothesizing that doing statistics causes you to have more fun and drinking coffee causes you to have more fun, well, then you're back to deciding if these are continuous or categorical and going from here. So are these IVs specifically? Again, IVs are category. Like if you're worried about DVs, don't do it in this case. Just worry about IVs. The DV here is having fun. Just leave that as it is. The IV, if the IVs are continuous, you go one way. If the IVs are categorical, you go the other. In this case, I said number of hours. If I say number of hours doing statistics and number of gallons of coffee drank, well, not gallons, ounces. Those are continuous scales. So then you do multiple regression and you're done with the decision making there. Pretty straightforward if the variables are continuous in this case. If they're categorical, then you go two-way ANOVA. So categorical would be like, did I do statistics or did I not? That would be one. And then the other would be, did I drink coffee or did I not? That would be the other. If, let's say, one of the IVs is continuous but the other's not, then you go multiple regression. So multiple regression is at least one IV is continuous, technically. Okay, so if they're both continuous, or I'm sorry, if they're both categorical, you go ANOVA, and then you have one more decision, and it's kind of like what happened if you went ANOVA for one IV. You have one more decision, and that is, are the categories independent or not? There's this word independent just keeps coming back too. Like, is it an independent variable first? And that's a separate decision. Then are the samples independent? I get it. I understand this is weird and repetitive and confusing sometimes. But anyway, feel free to rewind my video if you get lost and you want to go back. That's the beauty of YouTube. Okay, so we've determined we have two IVs and they're categorical. So one is I do statistics or I don't. The other is I drink coffee or I don't. Categories. Are they independent? If they're independent, well, you make this decision twice. Once for the first IV and once for the second IV. So the first one is independent if, like, we have a group that does statistics and we have a group that doesn't do statistics. Independent groups, they don't know each other. There's no dependence there. And then for the other ones, the same thing. We have a group that drinks coffee and a group that doesn't drink coffee. Independent groups, maybe they're completely unrelated. Hopefully they're unrelated. They need to be unrelated groups to be independent. If they're both unrelated, then we go categories are independent, and we do a two-way independent samples ANOVA. To go dependent, it would be like me over time or some repeated measures. So I do statistics today and I drink coffee. Tomorrow I do statistics but I don't drink coffee. The third day I don't do statistics and I drink coffee. Fourth day I don't do either one. So it's me repeated over time. That's dependent, right? Maybe I have certain characteristics that we should account for across time. I like to have fun. I like to do statistics. I like to drink coffee, whatever. That dependence, the fact that it's the same person, then causes us to do a two-way. Dependent samples ANOVA, the stats change. And then sometimes you have one of each. You call it a mixed samples ANOVA. So suppose we have two different groups. One does statistics and one doesn't. But then they all drink coffee today, and then they all drink coffee, or they all don't drink coffee tomorrow, and we compare today against tomorrow. Okay, I'm tired. But that would be the one IV independent and one IV dependent example. And then, like I said, on this chart, there's just a bunch of other hints. I would call them hints. This is not necessarily a guide to how to do all of these. It's just like, now that you've determined which test to run, here is the edge of what else you need to look at to get started. So what the hypotheses look like, test statistic looks like, and the SPSS stuff. And then I have a little example here for each one involving dog ownership and stuff. So check that out, see if it helps your understanding of the differences between these tests. And then with this roadmap stuff, like be patient with it. Like if you're given a list of word problems and the first time around you get like 5 correct out of 10 or less, something like that, like in terms of guessing which test to run, don't worry about it. Come see me, come talk about it. We can go through these scenarios and examples. And over time you'll get it. It's one of those things that you learn the first time and then it's not easy. So you go the second time and then you see a new word problem. And then finally after repetition, you get it. So don't lose heart, stick to the process, rewind my video and watch the beginning again. Just spend time with it. It'll come. So, all right, that's my encouragement. Let's all go do some hypothesis tests.